Okay, so this is 14.1 video 2. So we're going to continue the ideas of multiple variables in this one. First thing I want to talk about is this thing which is called a contour map. So what you're looking at basically would be um, kind of like if it was some kind of a hilly region or something like that. What you're looking at is something directly from above. So you're looking straight down at the XY plane. And what these numbers, sorry, let me get to a pen. What these numbers right here represent are the height. These are the Z values, or the height of whatever this topographical map looks like. So basically that's saying that has a height of 50. Then if you look in here, this piece right here has a height of 80, then 70, then 60, then 50. So if you can kind of get the idea, this thing is on the outside, it's low, and then it starts to increase. So basically it's starting to go up as you go in that direction. And then it kind of plateaus at 80, and then it looks like it comes back down to 50 in here. So if you were to look at it from the side, it probably looks something more like this. Something like this, where this right here would be your 50 height, and these right here would be your 80 height. Something like that. All right, so that's kind of what the contour map is doing. So now if we go back, and I realize I went out of order. I apologize. I should have told you go to your last page first. Now if we go back, what we're going to do is we're going to do a little matching. And the idea is let's match the contour map with the actual three-dimensional map. So we're given 6 three-dimensional maps, and then we want to see if we can match what the contour map is below. All right, so you kind of have to piece some things together. So it looks like, let's take a look at one that probably won't be that difficult to figure out. So it looks to me like something like letter C here. If you come across the center of this thing, it looks like it's pretty flat, pretty low around the x-axis. Also looks like it's pretty low around the y-axis, right through there. And then it looks like it starts to kind of go up and down as it goes almost on a 45-degree line. So almost on a 45-degree line, it's going to go up and down and up and down and up and down. So just kind of looking at that, it looks like maybe, let's see, we've got, I'm thinking it looks like number 2. Because it looks like on number 2, on the y-axis, this is pretty flat. On the x-axis, it's pretty flat. But then as you go out on a 45-degree line, it looks like these contours are going up and then down and then up and then down and so on all the way through there. So I'm thinking that that letter C here is probably number 2. Or put a C down here. I don't know how we want to label that. Let's see. What other one seems to make sense? Well, E actually looks like it probably is the one that makes the most sense because it looks like it's just a whole bunch of hills and valleys. And the only one that I can see on here that looks like a whole bunch of hills and valleys in a pattern where it's left and right, up and down, all that kind of stuff looks like number 3. Okay, I'm pretty sure that number 3 is E. Let's see, what else would make sense here? Let's take a look at, I guess we'll just go to A. So A is pretty interesting. A has what looks to be like a pretty, well, it's not really flat on the y-axis. It does have some hills going in the y direction. They're not big. They're kind of gradual in the y direction. But then they start to get quite steep in what would be the positive x direction. So they start to get very, very steep in the x direction. Let's see which one that might look like. I'm thinking it's got to be 4. So it looks like they're not very steep here. Like these would be very gradually going up and down in the y direction. But then as you get in the x direction, these things are much more steep. I know it's very difficult for me to, I'm not doing it any justice here drawing it, but hopefully you can see how kind of that fits together. So I'm pretty sure that letter A is 4. So we'll put an A down there. Let's see what other ones make sense here. F. What do we got? B, D, and F left. So I don't know. Let's look at B. So B looks like it starts up at the origin, then it starts to come down to the x-axis, and then it actually goes below the x-axis, and it does the exact same thing, it looks like, in the direction of y. But then as it starts to go further and further out in the x direction, it starts to get very steep very fast in the 45-degree angles. Starts to get very steep very fast. So let's see which one would look like B. In the 45-degree angles, it starts to get very steep very fast. So it looks like it goes up, then down, then very steep very quickly. Up and down and very steep very quickly. Very steep very quickly. And how can I tell it's getting very steep very quick? Well, the basic idea here is the closer the lines are together, the steeper it gets, the faster. The more spread apart they are, the more gradual the change is. Now, I can't tell by looking at number 6 here that these are going up and down, but what I can tell is that the change is very quick within this region. The change here is very gradual because you can see the massive distance in between the contours. So the closer the value, the closer those contour lines or curves in this case are, the steeper it's going to get, the faster. So I said that 6 was B, I think. And of course, we can always correct this if we find one of these to be incorrect. But I'm pretty sure that that's the case. Let's see, what else do we have? We've got D and F left, and we've got I, or 1, excuse me, and 5 left. I'm pretty sure by looking at F, that's got to be number 1. Because this thing looks like it's got a relatively consistent, very steep, not so steep, very steep, not so steep, very steep, not so steep, and it's a pretty consistent pattern. So I'm thinking that one's got to be F, which by process of elimination leaves D here. And it looks like within, right around where you've got the origin, this thing grows very quickly in the positive direction or very quickly in the negative direction. So it's very steep very quickly. And you've got a lot of really close contour lines right there. And then they start to spread out. As this thing goes down, it starts to level off, or as it comes back up, it starts to level off and get a little less steep. So that's kind of what you're looking for. It does take some practice as far as these are concerned. But again, the main concept I want you to get out of this is the closer the lines are together, the steeper it gets, either up or down, doesn't matter. And then the more spread out they are, the more level or the more gradual any kind of a change is going to be. All right, let's try one more set of these things. This time, we're going to be given the functions as opposed to the contour maps. So we want to match, there's no other ones on here. So we want to match these functions with the contour maps. I'm sorry, with the actual functions itself. Okay, so let's see here. The first one, A, is f of xy equals absolute value of x plus absolute value of y. Well, the one thing you should notice there is that there's not going to be any negative values because absolute values are all going to be positive. So at the very worst, this thing is going to be 0. And then it's going to continue to get bigger as we go. And they are absolute values. So if you know what absolute values look like. So let's just say, for example, y is 0. If we let y equal 0, then you've basically just got the absolute value of x. Well, if you look at number 6 here, if y is 0, which means you're only talking about the x-axis, you've got the absolute value of x. It's kind of hard to see, but that's what you have. Here's the absolute value of x. Guess it's going to go a little further up this way. Absolute value of x. And then if you were to let x equal 0, you'd have the absolute value of y, which would be the same general idea, but in the y direction. So it would be here and then up this way. Absolute value of y. Maybe I'm in the wrong spot there. No, I think that's the right spot. It's hard to tell. But hopefully you can see what I'm talking about. It definitely looks like it goes down. I think I did draw that in the wrong place. I think it comes up this direction on the other side there. You got your absolute value of x and you got your absolute value of y. So I'm pretty sure that that one has to be number 6. And also every single value is above the x-axis, with the exception of if x is 0 and y is 0, you would be at the origin. So I'm pretty sure that that one is A. So we'll put an A there. We'll put a 6 up there. For letter B, it's also an absolute value, but it's an absolute value of the product of x and y. So again, everything's going to be positive. In this case, if you let x and y equal 0, it will be 0, but as x and y get bigger, the function is going to get big very, very quickly, but it's still going to be positive. So what other possibilities do we have there? I'm thinking this is going to be 5, because it's the only other thing that looks like an absolute value. I'm actually going to come back to that one, though, because I'm not positive about that yet. Let's see. Let's look at letter C. The letter C is 1 over 1 plus x squared plus y squared. So nothing is going to make it undefined, because 1 plus x squared plus y squared in the denominator is not going to be undefined. So it looks like we're going to be okay there. As x and y, however, get extremely large, that's going to make a denominator which is really, really big. So it's going to start to approach 0. So it's going to flatten out as x and y get really large. As x and y get really, really small, it looks like we're probably going to be approaching 1. Well, if x and y are 0, then it's going to be 1. So this one has to be 1. I don't see any other possibility for that one. X and y are 0, you're here. As x and y get really big, this thing flattens out in all directions, whether x is positive or negative or y is positive or negative. It's going to start approaching 0. Okay, that's just kind of a limit idea right there. So I'm pretty sure that has to be C. D, x squared minus y squared squared. So once again, everything is going to be positive. In this case, I'm looking at these things, I'm thinking it's either going to be 2 or 4. And the reason for that is because along the line x equals y, if x is equal to y, these things it's going to be 0. If x equals y for letter D, you're going to get 0. So it should be a 0 or on the xy plane. What if negative x were to equal negative y? Well, you'd get the same thing. So I think this one has to be 4, because if x equals y, it's the 45-degree line right here. If x equals negative y, it's the 45-degree line, which is really hard to see, but it's in there. It's in between here, but it's flat. What you can see is hopefully that's flat in there. So I'm pretty sure. And then obviously as x or y get bigger and bigger and bigger, and they're not the same value, then these things are going to get tall very quickly. So I'm pretty sure this is D. So I'm pretty sure that's number 4 there. Let's see, x minus y squared. Okay, so that one's probably going to have to be 2, because in this case, it's only when x equals y that you're going to have 0. So that's along the 45-degree line here where x equals y. When x equals negative y, then you're going to end up with, so if we just write that, if x equals negative y, so then you would get negative 2y squared by plugging in negative y for x. So it's going to get big very, very quickly in either direction. So I'm pretty sure this one has to be 2, which is E. And then f, okay, yeah, that one makes sense. F is a sine function, so it should look like a wave. So I'm pretty sure this one here follows the sine pattern in both directions. That definitely looks like a sine function to me, which means that I think my original thought that V down here was B is correct, because it has to be by process of elimination. Again, not the easiest thing. You want to try and ask yourself some different questions and try and fit these pieces together. Use your concept of limits, use just regular function values, use what you know about the functions as they are presented to try and match these graphs and see what you can do. But that's it. It's a much shorter video than the last one. That should be plenty of enough information for 14.1.